What are the 9 advantages of multi-layer PCB? These intricate circuit boards boast a multitude of advantages that cater to the ever-evolving demands of the electronics industry. In this article, we delve into the distinct advantages of multi-layer PCB as preferred choice for a wide range of applications. In the dynamic landscape of modern electronics, the design and composition of printed circuit boards, PCBs, have witnessed remarkable advancements. One such innovation that has revolutionized electronic manufacturing is the advent of multi-layer PCBs. Multi-layer circuit boards are actually formed by laminating and bonding several etched single or double panels. So, what are the advantages of multi-layer PCB compared with single-layer circuit boards and double-layer circuit boards? Let me share it with you below. What is multi-layer PCB? A multi-layer PCB, printed circuit board, is a type of circuit board that consists of multiple layers of conductive traces, insulating material, and often additional components. Unlike single-layer or double-layer PCBs, which have conductive traces on only one or two sides respectively, multi-layer PCBs have conductive traces on multiple layers stacked atop each other. These layers are interconnected through vias, which are small plated holes that allow signals and power to pass between different layers. The inner layers are usually dedicated to signal routing, power planes, and ground connections. The outer layers typically host components, allowing for a higher density of components and more complex circuitry in a smaller space. The multiple layers in a multi-layer PCB provide several advantages, including improved signal integrity, reduced electromagnetic interference, EMI, enhanced thermal management, and greater design flexibility. Multi-layer PCBs are widely used in modern electronic devices that require compact size, high performance, and reliability, such as smartphones, computers, automotive electronics, and medical devices. Detail advantages of multi-layer PCB. Advantages 1. Enhanced signal integrity. One of the primary advantages of multi-layer PCBs is their ability to optimize signal integrity. These boards consist of multiple layers of copper traces separated by insulating materials, allowing designers to meticulously route signal traces while minimizing interference. This configuration drastically reduces the risk of signal loss, crosstalk, and electromagnetic interference, EMI, resulting in improved overall performance and reliability of the electronic device. Miniaturization not only brings physical advantages in terms of PCB size and weight, but it also improves the signal integrity of electronic devices. As components are made smaller, the distance between them decreases, leading to reduced signal degradation and improved performance. This is particularly important in high-frequency applications, such as wireless communication and data transmission. Advantages 2. Size and weight reduction. One of the most obvious advantages of miniaturization is the reduction in size and weight of electronic devices. Gone are the days of carrying around bulky laptops or struggling to fit a large television into a small living room. Miniaturization has allowed us to enjoy the benefits of technology without sacrificing convenience or aesthetics. Today, we can effortlessly slip a sleek tablet into our bags or mount a slim television on the wall, creating a minimalist and modern environment. Modern electronic devices demand compactness without compromising on functionality. Multi-layer PCBs excel in this aspect by accommodating complex circuits in a smaller footprint. With the ability to stack numerous layers vertically, these PCBs enable designers to achieve high-density interconnections, accommodating more components and functionality within a limited space. This is particularly advantageous in applications such as smartphones, wearables, and IoT devices. For portable devices and space-constrained applications, multi-layer PCBs offer a crucial advantage. By consolidating components into a smaller area, they contribute to reduced device size and weight, enhancing overall portability and design aesthetics. Advantages 3. Power distribution and thermal management. Another advantage of miniaturization in electronics is improved power distribution. By reducing the size of electronic components, it becomes easier to design and implement efficient power management systems. Smaller components have lower power requirements, resulting in reduced energy consumption and longer battery life. Consider the evolution of laptops. In the past, laptops were notorious for their short battery life, often lasting only a few hours before needing to be recharged. However, with advancements in miniaturization, laptops have become more power efficient, allowing us to work or play on the go without constantly worrying about finding an available power outlet. This has transformed the way we work and travel, providing us with the freedom and flexibility to be productive wherever we go. Efficient power distribution and heat dissipation are critical for maintaining the longevity and stability of electronic components. Multilayer PCBs facilitate the integration of power planes, providing dedicated layers for power and ground connections. This enhances the power integrity of the system, reduces voltage drops, and minimizes the risk of thermal issues. Additionally, the multiple layers act as effective heat sinks, dispersing heat generated by active components and optimizing thermal management. Advantages 4. Complex PCB design support. Modern electronics often require intricate, densely packed designs. Multilayer PCBs accommodate these complex designs more effectively than single or double-layer counterparts. Their flexibility in routing and component placement allows for the integration of advanced features and functionalities. The design flexibility offered by multilayer PCBs is unparalleled. Designers can route complex circuits with varying signal speeds, impedance requirements, and power needs, all within the same board. This flexibility fosters innovation and enables the creation of intricate electronic systems that meet specific performance criteria. Moreover, multilayer PCBs can incorporate both surface mount and through-hole components, accommodating a diverse range of components and technologies. PCB design techniques like controlled impedance routing, transmission line optimization, miniaturization, and integration. If you want to integrate more PCB solutions, multilayer PCBs play an important role, especially with the advent of the 5G technology. That is why PCB design manufacturing conquer 5G integration. Advantages 5. Reduced electromagnetic emissions. Electromagnetic emissions can lead to interference with other electronic devices and even pose health risks. Multilayer PCBs, with their optimized signal routing and reduced EMI, contribute to electromagnetic compatibility, EMC. By suppressing unwanted radiation and minimizing susceptibility to external electromagnetic fields, these boards help ensure that electronic devices comply with stringent EMC standards. Advantages 6. Reduced noise and crosstalk. Multilayer PCBs are adept at minimizing noise and crosstalk between signal traces. With dedicated ground and power planes, electromagnetic interference is reduced, resulting in cleaner signals and less interference between components. Advantages 7. Easier troubleshooting and maintenance. Miniaturization has made troubleshooting and maintenance of electronic devices easier and more efficient. With smaller and more modular components, it becomes easier to identify and replace faulty parts, reducing downtime and repair costs. Advantages 8. PCB manufacturing cost-effective. Contrary to what one might expect, miniaturization has also led to cost-effectiveness in the production of electronic devices. While the initial investment in research and development may be significant, the economies of scale achieved through mass production of smaller components result in lower manufacturing costs. While multi-layer PCBs may seem more complex, they often offer cost savings in the long run. Their ability to reduce the number of external electronic components, such as connectors and cables, can lower PCB manufacturing costs and PCB assembly costs. Moreover, their reliability minimizes maintenance and repair expenses. Advantages 9. Enhanced electronic component density. One of the primary advantages of multi-layer PCBs is their ability to pack a substantial number of components into a compact space. Unlike single-layer or double-layer PCBs, which have limitations in component placement, multi-layer PCBs offer multiple layers of interconnection. This means more components can be added without increasing the PCB's physical size. With each new generation of devices, we demand more functionality, more power, and more features. This often means adding more electronic components to the PCB. But where do you put them all? Once again, multi-layer PCBs come to the rescue. By adding more layers, you can increase the number of components that can be mounted on the board. This means you can add more functionality and complexity to your device without increasing its size. It's like adding more rooms to your house. You can have a kitchen, a living room, a home theater, and a games room, all without expanding the footprint of your house.